Good evening. Namaskar. Good evening. This is December 30, 2020, and this is Engineer Suraj Singh speaking from Bharat, India. This is Chartered Engineer, Professional Engineer, and I am presenting to you formula demonstration, and that is for various shapes. It is, entitled Mathematical Formula Demonstration, Equations, Geometry Shapes, Combination of Shapes A to Z, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and various combinations, and let's etc. etc. Before also, I presented to you various drawings about these, and those drawings were presented on JEDCAD, and before that also, I presented to you this file, which is a long one now, and if you go behind this home, you'll find that this is formula generation, validation by me, and that is Suraj Singh. All right, various dates for the 4th to 30th today, various dates, various submissions, various presentations, and like that. From scratch, we started. We started x square plus bx plus c, the scratch one, and then moved on to various other equations, and then we moved on to various formula, combination of formulas, and then of course geometrical shapes we entered. That's very dynamic. The various shapes from elementary square, rectangle, or circle to various stages of geometry, which can be used in calculations, in mensuration, or in engineering, or elsewhere. You can see these with certain drawings here. As you can see, square, rectangle, triangle of three sides, equilateral triangle, isosceles triangle, right angle triangle, and triangle where three sides are given, circle. Like that, various other shapes. We have seen them: sphere, cylinder, cone, and parallelogram. Then, of course, rhombus and trapezium of both equal and eccentric and others. Polygon, various shapes: five sides, 6 sides, 7 sides, 8 sides, 9 sides, 10 sides, and then combination of various like that combinations. You can see that here. There is combination starting like as it is here. Various combinations in shapes. You can see this. I showed you last time as well. These were discussed, explained, and I think if maybe find interest, may not find interest, that's another issue. But these were conferred onto you just how to do it, and I think it's an interesting one, though it may not attract many viewers, but it's of interest in calculations. It's very, very important. And once you compose such formula, it can be used any number of times. You can use many number of times and any way. That's no problem. It was there. Various integration of shapes in various forms, and it depends on to you how do you compose it, so that you can use it in your life, in your work, or otherwise. This is where it stands, and I'm just reviewing everything so that you may remember. Then we started A, B, C, D, not actual, there was just rectangularly, in rectangle square shapes E, F, and G, H. And we were at G last time, I remember. So we'll go again to A. We discussed with this A, and we see this is A here. You can see last time we discussed. This is A here with various areas mentioned in that. For example, area 1, area 2, area 3, area 4 here, and 5A and 8A. So it was discussed that time. And then like B, similarly, various areas, and C, D, etc. So in A, it was, it was clearly given that in this case, area like in a strip we kept 10 meter strip. Strip means continuation of that letter composition or letter shape. Strip, I mean to say, strip is here. This is a strip, This width is A, that is a strip. This strip moves like this. We consider this as a strip. We consider this as a strip, This as a strip. Similarly, this as a strip. So when we talk, this is reliable, and this is variable here. This width can be anything. So I am just naming it A, and using that strip width, I am proportioning all dimensions and all areas extra being calculated accordingly. So what I say when I say that letter A, its strip width is this, and you can keep whatever area 1, 2, 3, 4, and this area as I told you, and then I sum up this area. Also, then I take parameter here. Parameter means same dimensions are written as parameters and added. And if required internal separately, we take internal separate. Doesn't matter. Internal parameter, and then sum up the two. So we get parameter. So we have two values, areas and parameters. Then we take it into 3 dimensions. Third dimension extrusion. You can say extrusion means the vertical projection of planar figure. Which is here is planar figure. Here is planar figure. No. This is planar figure here. And if you extrude it vertically, it becomes 3 dimensions or 3D solid geometry. So we are just working on solid geometry here, so that this area is extruded. This area is extruded here, and let us extrude by 10 meters. So you get this value, total area into depth. That is volume. And then also surface area is important, because whatever shape you have, there are 2 ends of that. And that ends are areas, covered areas or solid areas. And whatever height you extrude, so you multiply by that, you will get surface areas. Surface area means both end areas and total perimeter into depth. So you get volume as well as surface areas. I'll just change value and show you. Here it is 10, I say 20, I say keep 20. You see all value change. If you give 100, all value change. Or if you give 1, all values change. Or if you keep it, see, changes and changes and changes, and that's what is required. Means you just need this open cell. You just know what value you want. All this work accordingly, and say I say 10. If I say here, no, I don't want 10, here I want 5. This will do. This value will change. No, this is how. So it depends, because there is no fixation of depth. It can be anything. It can be 100 meters also. Let us say 100 meters, and this is that one. So we do it accordingly. Wherever depth is relative, it works, For example, here, we only point is that you must be clear about formula. For example, here is area, which is here 2, 0, 0, G and K is this depth, and the same thing is there. Here is 2G, This one plus J into, here I kept 10, but I should keep it here 10. So it's like this, By chance it was 10, so I'm just that. So it is 2G same, but J into K. So if I change this 5, it changes, right? And if I change this 100, it changes like this. So this is what I have done. Same thing. So you can see area 1, 2, 3, 4, 5, 4. There are 4 areas in this. So area, 1, 2, 3, and 4. 1 is this, 2 is this, 3 is this, and 4 is this. And same dimensions have been used. Let's say 3A into A in area 1, and 8A into A area 2, and 3A into A area 3, and 8A into A area 4. Now you may say, what A is value here? In each calculation, when you put in formula, this is only for information here. When I use it in formula here, for example, 3A into A. 3A is this. A is this, so this is here B book 6 and 4 in this cell. In your sheet it will be different. So I put it twice because one time it is 3A, this is 3A, this is A. This is 3A into width of that is also, you got my point. What I said is, it is 3A into A. So you are moving only in terms of A. It could be 3A square, but I am just keeping 3 into A for clarity purpose. Same way, if you see here, 8A into A, you can see 8A into A, and here also 3A into A. Like that, it moves all the way. Here, whatever is there, inside same thing. You can see each formula here, sum of all these values, and here is, parameter. You can say whatever B, it is actually A, it is 8A, it is 5A, it is 8A, it is A, it is 3A, it is 3A, and it is 3A, like that. And then we sum of parameter, and we see if you multiply perimeter by depth, you'll get surface area of perimeter, surface and 2 ends, and this way it is done. Then letter B, you can say same way it is area 1, area 2, area 3, area 4, area 5, area 6, and whatever number of areas are there, same way values are there. So we worked out values here, formula is written, and then we can say, you may say whatever is a 3A into 8, for example, is 3A into A, it is 8A into A, for example, 8A into A, it is 3 into A again, then for 4.5 into this, and 4.5 into A. Like this we write all and add here, and then parameter if work out, 8A, 5A, 3.5A, A, whatever dimension you have given in terms of A, you have to add up here. And internal perimeter, external perimeter, because this is like that, so you can see here, you can say internal here and external here. Depends on you how you want to work out. Then you can say, then you say total perimeter is this and extrusion depth is 10. So what we say volume, here is area. Where is area? Here is total area, that is in cell I. So we say product of I, this value, and this depth is n. In this here we get volume. And similarly we get surface area. There is 2 into end areas, and then there is I619. Its end area is I619 here. This is that. And M is 619. M is perimeter, so we multiply by that. Here I multiply by 10, so I should say not 10, I should say this. So that's here, Because I can't keep this cell blank in terms of value. It should be in terms of cell reference. Then it's there, but there's a reference N 16. So here I say, I go that's here in surface area, I put like this, 2 into I619, this is here, into plus M into N6, this is this one. That's I can do like this, Go to C, I'm just revising, I'm just reviewing it so that you remember, I taught last time. C is, see, this is all the square shape I'm telling you now. We'll go to real shapes also after these shapes are little done, because that is a very interesting one. Composition formula is very important. If you understand that formula, I think that is what's required. Because if you don't understand formula, how to establish formula, how to, you can say, produce formula, once you produce it, you'll get benefit of that in future. You can edit whole composition, you can use it in whatever way, and you can copy it, paste somewhere else to form another formula. It is like that. You may amend something in that, but you have to be careful about cell references, because if you copy, cell references change, and if you just cut and move it like this, cut and paste, nothing changes, it remains same. So you have to decide yourself. Now you go to C, and you see 1 area, 2 area, 3 area, 3 areas are there, 1, 2, and 3, and these are values here, 4A into A here, the work of that one, 4A into A. Then we said, okay, this is 8A into A, and this is 4A into A, like this. We added them, we got this value. Then extrusions here, and this is your 1. This is say total area, we got this value here. So this is here, product F. F is this area, and that is, H. Multiply 2 by product formula, we got this. And here also you can say we have used this 2 into end area is F, and here G624 into H. We got this. So we got two values here. Similar way, now we move on to D. D, that is letter D, and we say shape of that is in square shape. It's this one. Here are corners, taper corners. We have to work out that one, right? Area 1, 2, 3, 4, 5, 6 areas here. One area, independent one. 2 is here, rectangular. 3 is here, that's inclined trapezium. 4 is another trapezium at corner. Then say 5 here, trapezium, and this. So 1, 2, 3, 4 trapeziums are here. And then this is rectangle and this is rectangle. It's like that. This is rectangle actually. That's also trapezium. All trapezium except this. So we have to see that way. So you see here, you see letter D here, and you say this is strip width, and we have to find H here. You will see that hypotenuse, two hypotenuses are there. One is H and one is H1, and then you have to see how to find H. We worked out first H hypotenuse formula, a square plus a square under root. That we find here first. Then the corner right triangle basis, we find that angle is 68 and corner triangle angle 22. 68 and 22 is 90, and tangent 68 we used here. Before also I told you this, just I'm just revisiting. So triangular base or perpendicular is a cot 68, and triangular base is called a cot 68. So we worked out trigonometrical functions here. Then we got H. Now H1 is equal to H minus 2 into base. So we got this value H1. So then this is area 4 we worked out, and then we worked out area 3. Area 4 is a trapezium. Area 3 is we worked out here. This is, and then area 5, area 6, and area 1. Area 2 is in sequence different because of that corner which is not rectangular. We have to work on all this, All this calculation was worked out for area 4. And area 4 is this area 4 for this. This is very, very critical in this case of D. And we go now. After working out the trapezium area 4, we got area 3, area 5, and area 6. Area 3 square meter said that is this value, it has the trapezium, and we got this 6 plus this over 2 and this. And then area 5, here we have the trapezium. Area 6 square meter, area 4, area 1, like this we did. All these functions we completed here, and then we said okay, and then total area we worked up here, that's this one, total area. You see there's no value entered here, all references of cells here, 1, 2, 3, 4, 5, so 1, 2, 3, 4, 5, what is this? And we got this value. Then after that we go external, we have a parameter, we got this area 1, 2, 3, 4, 5, 6, whatever. Then that is the parameter. We have here in this case external and internal value. You see this is external value and this is internal value. We have to work out that for parameter, sum of dimensions of external value, external parameter, and some dimensions of internal value in a parameter. So you can say external, say 5a, 8a, 5a, h, 6a, h, as in sequence. You find that, whatever it is, you will find this way, all like that, Then internal will find like that. So we will put in these values, and you get total here, this much, because we put cell values there. Whatever dimension is there, same we are doing here, and that's permanent there. You cannot change it after that. If you change, you will make errors, and this all sum. So this is external one. Then this is extrusion. That I'm taking external first, and then, for example, in this case, we say this separate and this separate. Extrusion is here, which is, you can say, volume cubic meter, how much? O60, and O60 is covered area here, or area here, O60, this area multiplied by this. We get this value here. There's no value, only references, cell references. So we now go to the previous one, that's the internal one. Internal is same as 10, 10, this we are changing because here we linked one. It's not independent, we linked over this one to this one. It says that B630, and also it says that B630. So we can say in internal 4a minus triangular base, and then 6a, now 4a minus triangular base, then h1, 6a minus 2 base. All these according to sequence of your geometry, you have to enter these values. So these are entered accordingly, and how we fought it. Whatever is written here, formula that we have to use here for purpose of calculation, working out that value, and you can say like that, you get all values done, and then parameter is internal to external. This is total of external, and this total of internal. So this is total of both this and that. So now extrusion, here is same 10. So we can say subsurface area. What surface area? 2 into n values, 2 into n values 060 here, this here n values, and plus you can say plus this is perimeter total. So this is perimeter total. A plus perimeter total is here, and then you can see the perimeter total here, that is 2 plus this into M636. This is the value, extrusion value. So we got this answer here. If I change 10, so to make 5, it will change. So okay, so let's see, this is what we have done. So now we go to letter E. See the E, F, G, like that, E is also, there is no curve in that, there is no taper in that, so it's square straight. So we'll do square straight, no problem. Now, so it says E, and here is E. I'll show you where is E. This is E here, you can see very simple one. It's E, 1 area, 2 area, 3 area, 4 area, A and 5A, 8A like this, and it is there. So we go on to like that. So in E, it says strip width is 10, same, we keep same everywhere. Area of 1 is 4A into A, area 2 is 8A into A, area 3 is 4A into A, area 4 is 4A into A, and total area is 1 plus 2 plus 3 plus 4, right? So we have to now understand, now we work out each area is 4A into A, for example. You can say here 4A into A, 8A into A, 4A into A, and 4A into A. And some of these all values, so C to F, C 644 to F. So we got some parameters here. I'm just giving elementary procedure here for your understanding. Yes, I'm not taking all these values in one cell. I'll take later on. Now I'm just giving you how to calculate that. So whatever dimensions are there, you've seen here these dimensions. You have seen here these dimensions. Whatever dimensions are here, you have to put in each cell, each dimension. I know that's an important point. So we come here and see how, you see here, this is 5A, start with 5A, then it moves to 8A, then it moves to 5A, A, 4A, 2.5A, 4A, A, 4A, 3.5A, 4A, and 3. This is what dimension moves about, So you have to care about these entries, because these are references. So now we look at 5A, for example, 5A is here, it is 5 into value of cell. Similarly, 8A, here is 8 in value of cell. So this is 5 is same value, this is A same value, 4A, it's like that. Sorry for cough. 2.5A, 2.5A, regret, 4A, and then A, and of course 4A here, and you put all such values and you find answers. 2.5A, that is here, and this all such values, and then these are added. For example, 6I to T, this is T and this is I. So we add all these values of parameter and we get parameter of 420 in this case, which is reference value. Then now we say 3-dimensional, let's say axis. Extrusion is 10, so volume is, where's volume here? Let's see volume, where area is there. First of all, total area is this. This is G, here is G, and V is saying V644, so here is V. This is V here. So we got this value. Then you got area, both had areas as given here. In this, both areas are given here. So that's this one. This 2n area parameter and this 2n area is 2g value here, plus u is here, this is u and this is v. So we got surface area, total surface area required one based on this E value. So we have to take it like that. Alright. Now we have to go to F. F is also easier, it's not difficult one. A of this and this. You see, here is dimensions are to work out first of all. It's given though in this case 8 is this and 5 is this. 5 and 8 is normal dimension here. 5A and 5 strip A and this. And we say 1, 2, 3. In this case, 3 areas are there in the case of F. So A strip is there. Area 1 is 4A into A. Area 2 is 8A into A. Area 3 is 4A into A. So we say 4A, this is A and this also A. So 4A into A, 8A into A, this is 6, 4B into B. And sum of this is 4 plus 8 plus 4 plus 8, this is 1601 plus 2 plus 3. And parameter will work out similar pattern as we did before. And that's a 5 dimension, 8 dimension, 8 dimension, 3.5 dimension, 4 dimension, 8 dimension, 4 dimension, 2.5, then 4A and A. This is what's this. Now, how does it work? How this works, you see this, you will see how it works like this. You have to understand that our way. Just think, keep thinking, and A, 5A, 8A, A, like this, it moves on. You should not tell me something, but you should take your value, and then let me see how it works. Alright, so you've seen this F, now I undo this, so you can very well understand what I say F. Now, F is there, area 1, area 2, area 3, you already seen this. So there's so this is what we say area 1, 2 and 3 and total area and parameter as we say as it is 5A, as we said 5A, 8A, 3.5A, 4A, 4A, 2.5A, 4A, like that. So we put values in this and values here, 5A is 50, then 8A, then 3, A and then this. Every cell is giving you value in that cell. And okay, so let's now, I think I made some mistake here. Let me go some entry. Okay, we'll go there and see how it is, So no problem, we'll go and see how it works. So it is here, F, I was on F, so this is F here. So we can see how it works. Same way, we cover for parameter here of all values and extrusion the same way. So we say area issue 5 and F and S, this is S and there's F. And we got area is F, area is F, the C is confirmed or not. There is area, this is area which is F. So F into S650 and this S is here, value it is F. Right. So we multiply same way here, F value here, R and S value here. R is this parameter and S is this. So we can say F is also done. Then G is a rectangle. G rectangle here, which is we took rectangular shape, square shape. We say this is that one. This is this one. A is that, and this is 4A, 8A, and 5A, and 4A, and half A, I think, A this way. This is what we do. So 1 area, 2 area, 3 area, 4 area, 5 area. See, 1, 2, 3, 4, 5 we have. This is with, this is vertical rectangle, this is 4, this is now, and like this. So we take care of this way, and then we see how it's done. So we say area 1, area 2, area 1, area 2, and area 3, and area 4, and area 5. So find out this area of this demonstration. Okay, now G, we say area 1, area 2, area 3, area 4, area 5 as also. Area 1 is 4 into A, area 2 is 8 into A, area 3 is 4 into A, area 4 is 2 into A, area 5 is 2 into A. So we keep these values in here. With this again the same variable, and here is this value, and this value. And the sum of all these values 6C to G, C to G. We have to work with parameter, same formula 5A. It's 5A, 8A, 5A, 4A, 2A, 2A, 3A, 6A, 6A, 6B. In this case, variables are important here. Variables are very important, and this is what we say formula-wise. With each value, like that here, and we come up value of physical tremor. What physical tremor here is? That's point, very, very important point. Is calculate G. This is what we calculate G. It's important point is that. We working of area and parameters is a long way because of dimensions, and because here is what we say. This is very calculated. Same thing by extrusion. Covered area multiplied by, we say H. H is covered, H is area of lighter. You can say H is area of lighter here. Because that, and you can say 2 into, let's say, so you got this value of G, right? I think you're convinced with that. This is G. We go to H. Last I think we held at G, so we cannot do that. Now I'm going a long way today. Means it's not only G or something. It's going to be many more in this case. Okay. Many more in this case now G. So we go to H. This is H. You can see H how it works. H like this, A, 8A like this, 3A, and this, and this is 3.5, this is 3.5, and this is so this is your H. Area 1, 2, and 3. So we got area 1, 2, and 3 calculated here. That's why it says it's square shape. I written here is square shape, and there's no square shape, it's a real shape. So now I'm discussing square shape first. I'll take up in this text talk your curve shape also. So you must have a little patience in this regard, because curve shape is a little complicated in calculation. It takes more time, more formula. By square is easy. It's just rectangular. You can see this as in a brief. So we can say H, 1, 2, and 3. No problem. whatever number of areas you decide yourself. I'm just giving my program, my criteria. Here is 1, 2, and 3. So 8A into A, 8A into A, then 3A into A, and then 8A into A again. Total is one of these three, C to E, C, D, E, and we get this value. And the parameter same, A, 8A, A, 3.5A, 3A, 3.5A, A, 8A, A, 3.5A, 3A, 3.5A. So these are values, and we convert these values to reference values on this dot V662. Similarly, here H into A 3.5A, these values go on. Press, enter the cell values, and then you can say total parameter. This is total parameter here, sum of H to S. Here's S, and here is H to S in this reference, and we got these values here. Now extrusion is here. So area F is area with which show F is area here. So we can say F and U is here, extrusion value. So we got volume, that is D, area into D. And surface area, same way, 2 into end areas and perimeter to D. So here is same value F to F, 2 times F, it means bottom and top, surface of plan as the figure, and then T62, which is this value of perimeter, and U is here, we got this surface area, and that's what we did here, and it's okay, fine. Our H is resolved. Now we are talking of I. This is what I say I, You can see it here yourself, is I. This is 5A, this is 5A, this is total 8A, here is A, and area 1, area 2, area 3. You can see yourself this area here. You can see here, and I put undo here again. So we go to solve this I. I mean, it's a square shape. This is still the same strip width, which is variable, and area 1, area 2, area 3. 5A into A, area 2 is 6A into A, and this is area 5A into A. 3 areas are both in values, are not values in references, and we get area 1, 2, and 3 sum up here, C to E. And we same way we say here 5A, A, 2A, 6A, 2A, A, 5A, A, and 2A, 6A, 2A, A, whatever values there, and then you have to enter references here, and that is 5A, cell references and location references, you can say. Then all this you do in this case, and we get a sum of all dimensions here, that is H to S. This is H, and you can say this is S here. And I'm not speaking the reference number cell because it can vary, so but here it's also, this may also vary, but still I'm giving for references. So H to S we summed up here, and we got this value. Now 3D, this is extrusion. Here's this little F, this F there, that's area F. You have seen that F is area here, and sum of areas, and then you can say that here multiplied by this, says get U, we get this value, and then of course 2 into F and P and U multiplied together, we get this value, and so we got current requirement, we got requirement of I is resolved. Now we go to J. J is also square one, not curve one. Curve I'll take later on. I'm just giving you what you have to do here. So you can see it's safe first. It's safe is this, You can see, maybe not see. Here you can see, and this is here, hold on please. Yeah, it's there. Maybe I take this way, so just for clearance. It's 1, 2, 3, 4, 5 areas, 5A, 8A, and this is 4A here. So we can just move on with this. So we can say here, we move on to this. Last time I showed to you on JetCAD. This time I can't show you that because of restrictions on document sharing. only one format can be shown. I cannot interfere in this format now. If I interfere in this format and open AutoCAD, I mean drawing, this video shall cease. And that's where problem lies in understanding. So I just copy from this drawing file the shapes and put on Excel, post on Excel, so that you can, of course it's not very clear in this, but whatever shape it takes, size it reduces, but because it's variable, it doesn't matter. It's in terms of A, so it can be whatever size, you can enlarge it and see that one. Now it is letter J, we have done it. Oh, sorry, we had to do it. And it's say step width here. Area 1, 2, 3, 4, 5. We saw five areas here. So area 1 is 5A into A, and you can see this 5A into A. Area 2 is 6A into A, this is 6 into A. And then you can see area 3 is 5A into A, so this is 5A into A. Then it's 2A into area 4, this is 2A into A. And area 5 is 2A into A, and this is 2A into A in references. And then sum is here area 1 plus 2 plus 3 plus 4 plus 5. And this is here sum of all these cells, C to G, and you got this value. Similarly, here I have given here parameter, so same way, same principle, nothing different, and same cell value. You can say references here is 5 means 5, and this is 10. I will say 1 means this, and this is 4A, 6A, like that. All are references, no value in that, just references. And then the sum of these references, you find here sum J to U, and this is U, and we started with J, this is J, so we got this value. We got this value here. Now you know area into depth, and that's here H is area. You can say again, confirm it, H is area, this is area, and you can find volume by taking this multiplication. So this is H and H and W references, and we get volume. It's very easy, not difficult. Same we have is twice n values here H, and then V into W, and we get this parameter surface plus end surfaces. So J is result. Now move on to K. JK. I think I might have given you this, but maybe let's be again. This is K. This is K. You know, maybe it's there complicated, but it's here. You know, K. You can see shape here. You know, how it works. You know, I have taken dimensions: area 1, area 2, and you know, area 3. Here, 1, 2, 3. Area 4 is here. Area 5 is here. You have to be very clear about this. What these areas are. Area 1, area 2 is leaving that corner triangle, and it's up to here. Then area 3 is this triangle, area 4 is this triangle, and area 5 is this one. This is, they have dimensioned it, not for you. This dimension is only for taking references. This dimension will change depending on your value of A. So that is only for reference. For example, I'm taking here, for example, 64.85. I will take 6.485A. If I take here 46.56, for example, I will take 4.657, depending on the value of A is. If I'm picking A value 10, I'll use that one. If I keep A value 5, then I'll use that one. So it depends upon you what value you do. If you use 10 value, 5 value, 20 value, 30, all will change on itself, and you will find this one. So we have to work out here what? We have to solve this triangle. We have to solve this triangle. We have to solve this rectangle. We have to solve this trapezium here. You know, this and this trapezium. Then we have to solve this trapezium here. So this trapezium we have to solve, and then we have to solve these triangles. Come on. हाँ सो कहीं रख दीजिए आप सो कहीं उधर रख दीजिए वहीं रख दीजिए आप हाँ रख दो इधर हाँ so this is the references 1 2 3 4 5 so these are dimension. Well, every dimension is given only for reference purpose, and we shall take care of this one. Now it's 1, it's 2, it's 3, it's 4, it's 5. we have to take care of this because this is not direct figure, this is inclined figure here. This is vertical. You may say this is rectangle here. This is trapezium here. This is this right angle here. Because it's right angle, my dimension is as well. And this is 5 and 4. So 1, 2, 3, 4, 5. 1 is a straight, 2 is not straight, 2 is trapezium, and 3 is triangle, 5 is trapezium, and then 4 is also triangle. So we have to take due care of this. And that's what I tried to explain to you. So in K, it is a square shape. I'm writing a square shape because there's no curve in that. Whenever I say square, it could be trapezium, though it's not square, but I'm just considering rectangular, or square areas, or trapezium as rectangular or square shape. So it's just for nomination. Now shape is 10 variable, that is, strip width. So area 1 is direct, as you saw, it's rectangular, so 8A into A. The area 2 is a trapezium, so it's an area 6.485 according to that dimension. Let us show you again. I said 6.4 because this dimension is here, This dimension is, let me do it up again for clarity now. You can say that, 6.485 like this. So I take a 64.85, 6.485 I'm taking this way, and this 46 point, this whatever is there, I just divide with value of A and put here. This you have to do, whatever value you have. I say then area 2 is trapezium, so 6.485A plus 1.414A plus A. I think this dimension according to that was you have to add up two sides of trapezium. This is one side, other side, and divide by 2, find sum of the half, and divide by 2 and multiply by A. That's what it is. Same way, area 3, that is triangle, half into base into height, half into A into 0.414A. We got here this value in these cells. Area 4 is a triangle again, half into base in the same value as here was. So it's here. Area 5 is a trapezium, is 4.657A plus 4.243A. Sum of these two into A is what's here. Now, total area square meter is areas 1 plus 2 plus 3 plus 4. All these areas, all these areas are added here. 1 plus 2 plus 3 plus 4 plus 5. And that's why I say here, whatever value you got here, you can see you got this value of rectangle, this value of trapezium here, you can see this value here. This is trapezium value here, and again, this is another trapezium value here, triangle value here, half into base into height, and then half into base, wait a minute, maybe I made some mistake, I think, 0.414, hold on, let me see what's that. Yeah, I think it's divided 4, maybe 4.14 is that. That's to be sure, first of all. Maybe anybody can make mistake. So 4.14, hold on. And this is, 4.14. So it is 4.14 here, and it is, 4.14, and this is 10. So 4.14 is dimension and 10 is dimension. We have to take care of that. So that's 4.14 and 10. So this means 4.14, 10. So take care of that actually. And it is 4.14 is here. So it's 0.414 it is. And 10 and 1/2 base. Half into base 10 is A. Half into base, that's 10. And height is 0.414, 414. A 414A. It may take some time to check again and again because 4.14 it was, so it is really 0.414. When divided by 10, there was a 10 which is A. So it's okay, it means there's no error in that yet. Better to have second check. So 0.414 is that one. So 0.41A, it is half into base, which is A, I think, half into base into half into base, it is half into base into two bases are there. One is height 414 and then half into A, half into A. So here I think I have to add this one, and this is A. So half into A into 0.414 into that one. So that's actually value. So, sometimes we miss something, so we correct when we re-look at that. So half into this base, half base B60, this is A1, a half into base, what was half into A. This is A actually, half into A, that's 10, and height is 0.414, and A. So this is that one. Similarly, other triangle is same, half into A, so maybe same thing. I think we have to do again, same here, or we can just put in like this. If we don't do like this, we put it like this, plus this here. So we can say area 3 equal to area 4. We can say area 4 equal to area 3. Area 3. We say simply so that automatically there's a change, it can affect itself. So area 3 it is. So we can say this area, this area and this area are equal. That's what's required here. This area and this area are equal. Hence we can say, if we change, there's some change here, also will come here. Now the area 5 is trapezium again. So 4.657 A plus 4.243 A divided by 2 into A. And let's say 4.657 into 7 into B A, and for B680 is A, and 4.234 into, says B6 over 2 into B680. So we got this value here. All right. Means we have to understand our procedure. First of all, it's an important one. It is a very, very important one. To understand that one, right? Okay, then we go further, and we can say area 5, which is of course done, the area, total area here, as the sum of C this one and G this one. So sum of this all is this. So we got here. Now same way, parameter, we have to find out parameter of all these sides, and this is the same system used. A is A, and here is 8A is 8A, and is A, and here is A, and there is this is 2A like this, and it's like from the whole A, and then you can say same way here, and we move further and get this one, and we move here and we get this one for it. Like this, all areas are there, and we can just check that one. You should write or not every time. Means if you compose formula, after formula is composed and you validate this, in that case there's no need as such. So A is there, it's here, and then it's here, and we get like this as usual, and we get this one here and this one here, and we can say here this like this and this one. So, and this is sum of all these, and the sum of all this is this, which is from J to W. This is W, and J is here. That is J. So you get parameter sum all summed up, and the dimension, we say this is extrusion, and here is area, which is H. Area is H. That we can't show this. H is area is fine. H is area, and we can say here that this is your H and Y. This is Y. So you get volume here, and same thing for H, twice H plus X here, and your Y here. So you get parameter, and K is resolved in the way. So now we go to L. Okay, I'm just moving on square. This is L. It's very small here. Means the economy. This is a little one. So this is one area and two area, 8A and 5. Very simple like this. So don't worry about this. Very simple here. L is very, very simple. And here is a strip width, area 1, area 2, and total area. Area 1 is 8A into A, so this is 8A into A. Area 2 is 4A into A, so 4A into A. So 1 plus areas, 2 areas, 1 plus 2. So this is sum C and D. C and D, we got this one. Same way parameter is A, 8A, 5A, A, 4A, 7A. If you have a picture in your mind, diagram in your mind, you can just write yourself without looking at figure, but better to check with that. So this is A, this is 8A, this is 5A, this is A, this is 4A, and this is 7A, and the sum of all is G to L, and just G, and this is L. So you get this one and get this one right. Then we go to extrusion here. Extrusion, and this is volume, which is here E into N. And you see what value of E is there a sum? So we can see yes, E is sum, and we can find out volume then. its volume here, E into N is this, and then you see is that twice into N value, which is E, and then we can say M is here, and N is here, you get this value, so L is the result. So we have jumped up from J to G to L. Actually, we have done A to L, but actually we started H, I, J, K, L. Now M squared 1. This is M squared 1, which is here, you can say, this is M. 1, 2, 3 areas, 4 areas, actually 1, 2, 3, 4. 9, it's a 9A, 1, 2, 3, I think it's 9A and 8A. 9A and 8A, you have to see that one, how to do that. So let's say this, okay, like that. Now let's do that. See, this value of M is to be A1, A2, A3, A4. 4 areas, a step width, and there's 8A into A. This is 7A into A. This is 7A into again, and we get 8A into A. Symmetrical, it is the same parameter. So total area is 1 plus 2 plus 3 plus 4, which is here C to F, and we get this value. The parameter same way we move, and we can say that 9A, then it is 8A, then it is A, then it is 7A, then it is 3A, then it is 7A, then it is A, then it is 7A, 3A, then 7A, A, then it's 8A, like that, And we come here, we see sum of this, say I and T is here, and I is here, yes, it is I. So we get this value. Here is 10 extrusion. We also formula is G into V here. Where is G? G is here, you can say. Is J here area? So we are taking that one. So this is your area, volume done. And surface area is twice that area plus U into V, and get this M surface area done. And now N, we move on to N. Let's say for N. Relax just for 2 minutes if you want. No hurry. No hurry at all. You can relax if you wish. Now is N. We see geometry of N first of all, and that's geometry of N. That's this one. 1, 2, 3, 4, 5. 9 and 8A. 1A is 5 is this 1, 2, 3, 4, 5. So we go back and see how it works. How it works. No. It's N 1, 2, 3, 4, 5. So one is 8A into A, 8A into A. Other one is 3A into A, 3A into A. Then it is 3A into A. So this is 3A into A. This is area 3, area 4 is 3A into A, 3A into A, area 5 is 8A into A, and this is 8A into A, area 5, and this 8A into A, this is 8A into A, and there's sum of 1, 2, 3, 4, 5, and there's this one, the C to G, and we got area and parameter similarly, we have to see parameter. Same way, 8A, A, 7A, 7A, 3A, 3A, 7A, 7A, then 5A, 5A, then 8A, 8A, then AA, and then 7A, 7A, then 3A, 3A, like the 7A, 7A, then 5A, 5A, like that, we move accordingly, and here we reach sum of all sizes, J to U, this is U, and this is J to U it is, and we got this one. Here we got parameters, so what's the extrusion, and we got the area. Area was which one? This was area, that's an H. This H and W is extrusion. So we can say here, W is extrusion here. We get the volume, and let's say 2 same H into B and W of extrusion, and we get this value. So N is resolved. N is resolved. O. We have to state O, shaped O is squared one. Which is this one, variable 5 into 8, A into then strip width, so area 1, 2, 3, 4, and we can say fine, it's okay. So we move that way right now. A is area 1, 2, 3, 4. 1, 2, 3, 4. One is 8 into A, 8 into A. Other one is 3 into A, 3 into A. And then 8 into A, 8 into A. And then 4 into, that is 3 into A is 3 into A. And we got sum 1, 2, 3, 4. And that's from C to F. We got some parameter, style is same. You can say it is, 8A, it is 5A, it is 8A, it is 5A, and then sum of all, and that is J to M. J to M is J to M. We got parameter sum. Then we got, okay, fine, we go to internal layers, so this external or internal is that there may be different notations depending on your requirement. So we say this external side, this is external side. So internal also can take now. Internal is also same, 3A, 6A, 3A, 6A, 3A. So 6A is 6, this is 6, then this 3A is 3, then you can say 6A is 6, and this 3A is 3. And then you can sum of all these, and that is P to S, P, Q, R, S. And this, you can see the extrusion. Extrusion is area, where's area? Area is here. Area is here, total area is this inside G, so this is, although this is area 1, 2, 3, 4, and this is, I think, G, this is right, in O, G, total area is G, maybe we are wrong, we can check that one is right or not. It should be G actually, and this is G and V, so it's okay, and then it's a parameter here, parameter is here, that is, 2 into G plus U, and this is parameter, both parameter here, internal and external, so we get this value, so it's okay, or it's result. Got it? Yes, nice result. The gap, then O is over, we'll go to F. P, not F. O and P, P is followed by O. How was we do in this case? So we'll take care of that now. We take care of P, hold on for a minute. Let me see something's there now. Because it's a very serious issue. Means we should not miss anything, and when we are, though I'm demonstrating it, I'm trying to check if there is some error, because there can be error, any error by overlook or by misreading or observation. That's very important one from each and every point of view. So let me hold on please, just a minute. You can see this by that time. I'll show you what is P first. I'll put that diagram on so that you can view that diagram. It's an easy one, not difficult one. That's this diagram here, and you can see that one. Okay, I'm back. So P, you can watch P. You might have watched by now. Watch it more and get it more. As many times you watch, you be clear about that. It's now here. Area 1, 2, 3, 4, 8A, 5A, 3A. So you can say 3 to 6 and 2, 8, 5A. So P is there. We have to stick on P now for a couple of minutes. I start area 1, 2, 3, 4. Area 1 is 8, A into A. This is that. Area 2 is 3 into A, has that. 8 into A, 3 into A. Then area 3 is 5 into A, has that. Area 4 is 3 into A, has that. Sum is 1 plus 2 plus 3 to 4. This is C to F, you get this value of area. Then go parameter, 8A, A, 3A, 4A, 5A, 5A. As many dimensions you get, and then you can say J to O, J to O. You got this. This is external. Now we say internal. Internal is 3A, 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 and then sum of all, and it is R to U. See sum of all, and then internal, external, P and V. This is V, and here is sum of all sizes P. So P into V, we get this dimension. Sorry, extrusion is here. And then we say where's the area? Area is here. This G. So we will take it's a G here. This is your G into X. X is here. So we get volume, and this 2 into G plus W. This is interexternal parameter plus into X. So we get this value. So P is resolved. P is resolved. Now go to Q. Q. This is Q. You can see this Q and how it is. You can see this shape is like this in rectangular way or in square way. And 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5 are there. So we can say how it works then. All right, we go now this way. We say area 1, shape is same, otherwise all descriptive and same. Area 1, area 2, area 3, area 4, area 5. Area 1 is 8A into A. Area 2 is 3A into A. Area 4 is 3A, 8A into A. Area 4 is 3A into A. Area 5 is 2A into A. And this is A, 1 plus 2 plus 3 plus 4 plus 5. And that is from here C to G. And we got this value. Now parameters, same way we move external and internal. So we can say external is 8A, 8A, 5A, 5A, A, and then 2A, 2A, and then AA, and then 2A, 2A, and then you can say 6A, 6A, and then you can say 5A, 5A. And the sum of this is from K to R. Is that. So we got this sum, that is external sides. Now we see internal sides. So 3A, 3A, 6A, 6A, 3A, 3A, 6A, 6A, and we got sum of all sides here, and that is U to X. U to X, we got this value, and we have summed up here then. This is S and Y. This is Y, and S is here, and this is your S. So we summed up these two internal, external one, and then we come on to extrusion, which is here, and H is our area. We confirm it. H is our area now. Let's confirm it. H is our area here, and we say okay, H is there. It doesn't matter. It's okay, fine. Then extrusion, and we get parameter here. Some parameter here is Z. So Z into AA, and we got surface area of Q. So now we go on to R. R is in this way. You can say this is R. Sorry, not this way. This is R. You can say R here. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Internal dimension is this. 5A. This is 3A, and this is 3A. This one, because it's 8, so it's 1, it's 2, and what's the balance is here equal. So 3, 3, and this is the so 1 to 5 areas we have to tackle, and we take it like this. So we go this way. Now the R square shape says area 1, area 2, area 3, area 4, area 5. We'll work out these areas. 8A into A, 8A into A, and this is 3A into A, and this is 5A into A, and area 4 is 3A into A, and this is area 5 is 3 into A, and this is sum of this 1, 2, 3, 4, 5 all, and this is C to G, C to G. Because the parameter X obviously external parameter. Same way it's 8A, 8A, A, 3A, 2A, 3A, A, 3A, A, 5A, and I'm just showing you references as well in 5A, and this because the reference should be clear. There should be no error in that. The error means it will not work, it will not function, we change it. And sum is this K to T, and this is T, and K to T is size, so it's K to T is okay. It moves like that, and say here internal is 3A, 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 and then 5A, 3A, sorry, 3A. So all are 3A, and that is 3A, 3A, 6, 3A. I'm sorry, I think 6A. How to 6A? This is I think maybe I've written 6A, but it's not 6A. Something wrong. 3, 3, 3, 3. So this is 3, 3, 3, 3 Asia, 3 Asia. So this is the catch. You can catch errors like this. You know how it's done by most side. So 3A, 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 and 3A, and this is 120. Have in this case W and Z. So we got internal external here. This is U and AA. This is AA, and this is U. You got this value for 40 here. Yes. And now extrusion is here. Then it's extrusion, and then you can say area HAC. AC is this H. You'll see confirm it H or no. That's very important. H is A, this area fine. H is confirmed, and then we can say that is H into AC. That's the surface area plus is the two end areas, 2 into H AB into AC, AB into AC. So R is done. Surface area is known. Now go to 5. S, letter S. Letter S. You see, we have come from A to S now. Which one is S actually? Should that's number 8, 9, and 9, 8, 19 number. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, 16. So 19 number it is. You can say, so 8 is here. As you can see, in star shape S. It's like that. 5, 8. And you can say area. You mark areas 1, 2, 3, 4, 5. So it's step direct A, so there's no confusion in this. We'll just move like this and calculate frequently all the 5 very fast, these 5 areas. There's no difficulty in them. Area 1 is here. This is 5A into A, and then area 2 is 2.5 into A, 2.5 into A. Then area 1 is 5A into A. And I'm just checking whether the references are not missing or not. Area 4 is 2.5 into A, and then you can say area 5 is 5 into A. Area plus all the total area is 1 plus 2 plus 3 plus 4 plus 5, and that's here C to G, C, D, E, F, G, and we get this value. And then parameter is important one here. Now I change my style. Instead of writing in each cell, I'm putting all this in one, so that is little. Now you know what you have done. Not need to take all these dimensions separate cells. I put in one, and see, for example, I said 5A like this and this like 5A, 4.5A, 5A plus 4.5A plus 4A plus 2.5A plus 4A plus A plus 5A plus 4.5A plus 4A plus 2.5 plus 4A plus A like this, according to this requirement. Let us say 5A here, 4.5 here, then 4A here, then like this, you move around and find this. So we check here 5A, 4.5A, 4A, 2.5A, 4A, A, 5A, 4.5A, 4A, 2.5A, 4A, and A. We got this value here. Extrusion is this, and this is H. Our area should be in H, and it is in H, no doubt. And so our area is confirmed, and J is multiplied by J is multiplied, and you can say 2 into and area H and I and J. We got this, and area plus parameter, so H is resolved. T is very easy. With just 2 areas, nothing else, so you can just calculate go area 1 and 2. There's 6A, 6 into A, 6A into A, then 7A into A, and here is 1 plus 2, so this plus the C to D, and we get this answer. And parameter 6A, I think 6A or whatever value it is, whatever value be there, it doesn't matter. 6A plus 2.5A plus 7A plus A plus 7A plus 2.5A plus A, and we get 6A, A, 2.5A, 7A, B, I mean to 1A, then 7A, 2.5A, and like this. We got this value here. Means it is your parameter value. Extrusion is here, so area here is this. This is your area E into G, and we get volume, and again E2 into E plus F into G, we get surface. So our this is resolved. Now hold on please. Just got 1 minute. I take some water. So this is here. Say, and this is U. It's also simple. 1, 2, and 3 areas as before, and dimension is 5. The 5A and 8A. The strip length is 3 with A. So 1, 2, 3 areas. 8A into A, 3A into A, 8A into A. 1 plus 2 plus 3, C to E. We got this, and then parameter, important one. A plus 8A, A plus 8A plus 5A plus 5 is this, plus 8A, A plus 7A plus 3A plus 7A. This is parameter A. Let us see. A, 8A, 5A, 8A, A, 7A, 3A, and 7A. We started from A, so we have got 1, 2, 3, 4, 5, 6, 7, 8 dimensions. 1, 2 this, 4 this, 4 to 6, and to 8. 2, 3, 4, 5, 6, 7, 8 dimensions. So this is here, you can say A, 8A, 5A, 8A, A, 7A, 3A, 7A. We got this dimension. Now this is extrusion and this is area. Area, which cell it is? Area is F into H. So it works, and 2 F and G and H. And so this is okay. This is done. U is done. Now V. Now V is not square one because V is complicated one. That's where it takes some time and V, and it's really, you can see first of all what we do here in U. You can see here, this is, how you can see, its dimension here, below a little more. You can see here, size is 9A, we have put 90, it is just for drawing purpose, and these dimensions are there. These dimensions worked out from drawing, but these are converted to A, all these dimensions. So there's area 1 here, trapezium. This area 3 is a trapezium. This is a triangle here, whose base is here and whose height is here. So we can work out area of triangle, area of trapezium number 1, we can trapezium number 3, and then we have these dimensions. And this also we have 10 is A, this one. So we can just work on to this. We divide this times by 10, and we can take in terms of, you can say, so it's that one. So got it? V. So we are working on V now. V, let's say, let's start step with area 1, area 2, area 3. Area 1 is a trapezium. Trapezium here. Trapezium 7.56 to A, one dimension, and 8.944 is another dimension, and we take division by 2 of this sum, multiplied by A. Same way, two triangle, this number 2 is there. Triangles are, it says half into base into height, half into base is A, because the base is A, of it base into A, and height is 1.2. This is given according here. You take this then. So it trap is another one, the same dimensions, and we take here. So we can say take here 7.562. So it was 75 there. 7.562 A plus 8.944. This over 2 into A. We got this one. Similarly, triangle half, it is half into base into height. So the one here we got this answer, and then we got the same way. So sum of this is C to E, and this one. This is complicated now. I say parameter is 1.118A plus 8.9448A plus A plus 8.9448A plus 1.118A plus 7.562A plus 7.562A, and this is all we enter here 1.18, 8.9448A, then 1 with the A and 8.944 again, then the 1.18 again, 7.562 and then 7.562. We got this one, and then extrusion here. Area is here, you can say F, area is here F into this depth, and then you can say 2 into area 2 is F, and this is 2 into F. 2 into F this, and G and H. G and H is here. So we got this. It's solved so quickly because homework was made, and it's this one. So now we move on to W, which is here, and W, you can see this figure first. Let me water. So we take now W. You have seen this W. This is area 1, 2, 3, 4, dimension 9A and 8A, and we can now work on this. Simple, not difficult. So area 1, 7A into A, and area 2, 9A into A, then area 3, 7A into A, area 4, 7A into A. You check these areas, and you see 7A into A, 9A into A, 7A into A, 7A into A, and you say 1, 2, 3 plus 4, and this is C to F. And then say 8A, we say how 8A is 8A plus 9A plus 8A plus A plus 7A plus 3A plus 7A plus A plus 7A plus 3A plus 7A plus A. And we got this value 8, 9, 8, 1, 7, 3, 7, then 1, 7, 3, 7, 1, 2, let's say 1, 2, let me say again 8, 9, 8, A, and then 7, 1, 7A, 3A, then 7A, then A, 7A, and 3A, 7A, and B. That one. So here area is G. So G into I, and this is 2G and H into I. So W is solved. Go on to other one. That is X. I use X in this shape, but that won't work in actual shape. It's like this, just for purpose of rectangular or square measurement was done. You can see that one, and it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11. 11 here, 11 areas, no problem, we'll solve 11 areas, no problem at all. I'm taking my medicine. And it is, you can say, good work if you do it, Once you do it, you will enjoy it. It says X, you can say A strip and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 areas. Be careful. So it is this one. No, I'll move like this. You see, it's this one. You can say it's like this. All right. Now I will take his area 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can see now a chain of areas now. 3 into A, 2.5 into A is 3 into A, right? Okay, 2.5 into A, 1.5 into A, then 2.5 into A, then 3 into A, 3 into A, then 3 into A, and then 3 into A, and then 2.5 into A, and then 1.5 into A. Then you can see 2.5 into A, and then this area is 11, 3 A into A, and we have summed up all this 1 plus 2 plus 3 plus 4 plus 5, 7, so up to 11. All sums here up to 11, and this starts here at C and M. So it says now we have to take into consideration our parameter, and that is total area is there, parameter is here. So we can say 3.5A. We start from here, 3. Oh, I'm sorry. This is may say so I start from here, I think. Let me see, 3.5A. This is 3.5A, and this is 3. This is A, 3.5. I start here. 3.5A, 3A. Yes, this is 3A. 3.5A, 3A plus A, and plus 2A plus 2.5A plus 1.102A. There is this one, 1 over 2A small portion, plus A plus again 1 over 2A, and then 2.5A, then 2A, then A, 3A, 3.5A. So these are all values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And these values we have to take like this only in this. And how far it goes down, I don't know, but let's see. It's okay, fine. We say how many values are there. And we'll, I think you see parameter left wing. Oh, I see, this is a different parameters we are taking. This is, left wing, it is only, this is this portion. It's parameter left wing. So I think 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This may be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This left wing, and then you can say 3A plus A here, 3A plus A 2 times, and then parameter other left wing is same as left one. So left wing same as say left one right wing actually parameter right wing and same as left wing. So we should say right wing it should be rather than left wing, writing error. So this is right wing. So this is right wing here, and right wing is same as left wing. So here this you can say 5. You can say 3.5A. 3.5A, then it is 3A, as this is 3A, then it is A, 2A, I'm just checking with that, 2.5A, half A, and A, then half A, 2.5A, and 2A, A, 3A, 3.5A. So we got this value, and that's okay. You can see how this got we got here. Now left is, we have seen this left one. Now parameter left wing is there, parameter middle wing it is, and this parameter middle wing actually. Sometimes mind stays but it doesn't write in. So parameter middle wing is 3A replaced. This is 3A and 3A, and right wing is same as this. So all add left, sum is total left wing plus middle wing plus right wing, and these are 3 O2 Q and we got this value. Now extrusion is this. Let's say where area was. Area is this, and this is our area in N, and then it is S. So we got this volume, and we get twice and this value, and R into S. This one we got this value. So X is resolved. Now Y. Why? It's very simple. You see, 1, 2, 3 areas, 4 areas, and it's very simple, so difficult at all. Why? Let me see what's stated in the It's 1 hour 30 minutes already left, no problem at all. Life is like that. So why? We have 4 areas. So area 1, area 2, 3, 4, and area 1 is 4A into A, 4A into A, and then area 3 is 3A into AB, area 2 then is 4A into A, area 3 and area 4 is 4A into A, and the sum of all 3, 4 is C to F, and that's this one. I would say parameters mark somebody. This is A, this is A, 4A, A plus 4A plus 2A plus 4A plus A plus 4A plus 2A plus 4A plus A plus 3A plus 3A plus 3. So we see all 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's okay. We can say now, let's say A, 4A, 2A, 4A, A, 4A, 2A, 4A, A, 3A, 3A, 3A. See, you got it, you see. So this sums up the list now. Area here is, G and multiply by this. And we got this value and 2 and areas and 2G into H into I with this area. So it's very simple, it's just solved. Don't worry about this. Z, we go to Z, last letter in shape of this type, and this that one you can say, you can just blow it further to see it correctly, because this is the inclined one as well. This is the one. You can say area 1, area 2, area 1, area 2. 1 is a rectangle, 2 is a trapezium, and 3 is also a trapezium, 4 is a trapezium, 5 is a trapezium. Actually all are trapezium. 1 is also trapezium, not rectangle. So all are trapezium, and dimension in and everything is in. You can see all dimensions are there for purpose of division by A. That's only purpose, no other purpose, and that's what it say. Let's go now. There, actually I'm taking this A as rectangle in this case, no problem. 5 into A, that is 5 into A. Area 2 is a trapezium, 0.746A plus 2.154A division by 2 into A, and then it is this one. You can say, sorry, this one. This is that one. You can see this here in terms of A, and we got this one. This was a rectangular term. This is also area 3, which is trapezium again. Dimension is 5.728 plus 5% over 2 into this. This is that one. Then you can say area 4 is here, which is also, you say, is same as area 2. So this is same as area 2. We put same value on the area 5, same as area 1. We put same value on this sum up of this parameter. You have to see. So we have to see what we have done here. That's very 5A. I say 5A. Say 5A. Starting from here, 5A and A. 5A, A, 4A. 5A, 4A is 0.746 in 0.746A. This here 0.746A. Then let me see 0.76. Yes, it's something. So 0.76A. 5.7288, 2.154A, 5A, A, 4A, then 0.746A, and 5.728, 2.8A, and 2.15. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 dimensions. That is how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 dimensions. Okay, fine, no problem, You can move it. Once again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe 12, I think. Maybe I'm wrong. Let me see. How much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are 12. My counting here was wrong. It's no problem. Let us say it's 5. It's 5, 5, 1, then 4.746, then A, and then 5.72, then 2.1454, then A, 5, 5A, then the A, then 4A, and 0.746, then 5, and then 2 point something. So it's okay. The extrusion is 10, area is, this means we take some area is in G, so G into this, here is value, and 2 into G here, H and I, and we get, and you can say H and I says because H is parameter here, and that's okay. We get this value, so Z is resolved. Now we are going to real shapes, which is very, very extraordinary. We go to A, B, I'll just explain to A, B, C, D, D, G, then J, then M, N, O, and P, Q, R, S, U, W, X, and then we'll go to 1, 2, 3, 1, 2, 2, 2, 2, because one is other one, 2 real shape and 2 square shape. Then we'll go to 3, and go to 4, 5, sorry, not 4, 5, letter 4, letter 3, and letter 5, letter 4, letter 3, I don't know, sequential, but I'll correct that one, there's no problem. Letter 3, letter 3, letter 4, letter 5, letter 6, letter 6, letter 7, letter 7, then letter 8, and then letter 9, letter 8 2, and then letter 9, and letter 9, and letter 0, and letter 0. This is so far worked on. A long list, maybe I need to arrange it tomorrow as well, because I was a Z now. I will start A again. I can't cover all in just one time. So let it be A here, square shape, okay, M N O P Q R S R S T W W X Y Z. Yes, here is A. Yeah, it's real shape. And what does it mean? What does it mean real shape? That's a shape. You see, this is the shape actually. This is that shape. But very frank, you view this shape first. That's very important. You can view successfully. It's fine. You can do successfully. And this is real one, means not squared one. This is how it goes in life, and that's dimension wise it is. And it's now how many minutes have gone for the video. It's already 1 hour 37 minutes. I'll do 20 minutes more because I don't know. Okay, now we have drawn A like this. There's a reason for that, and its dimensions angle is there, which I capped somewhere 76 degrees. You see here, this angle is 76. I put in here, and you can take whatever angle you want, but it depends on, means once you have to fix your dimensions, and that's fine, means how it works. And you can say here, this angle is 14, and there will be a 76, and the other one is 90 minus 76 is 14. There's a right triangle here, So areas wise, various dimensions are here. This height, this inclined is there, this is inclined is there, this inclined triangle side is there, and this is there, like this, This is A, I say, and this is A also, then is given, and whatever dimensions are given here, we have to fix them, and then we are using variables, so we can say this is 1, area 1, this is 2 here, you can see this one, just more, I don't know, if I little, you can see this, you can see A, 1, 2, 3, 4, 4, and 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. Got it. Dimensions are there. Don't worry about that. Angle is there. We'll divide this by 10 by calculating them, and that's all. It's now A gone. So we have to understand what we say. You take meanwhile, you can read yourself. This says something very, very extraordinary, because we are now starting inclined one and circular one, curved one, which takes some time. It takes some time in the sense that we have to be very careful about working out. Square we did, but this is curve one, this is trapezium one, this is real one. So it is now step same, area 1, trapezium. That is AO2 plus base, AO2 plus base over 2 into 1.881 A, and base equal to 0.97 A. You have to understand this point, and this what it says. What it says is that, this is our feedback for, this is feedback for, you can say, where's my internship here? This is, you can say, feedback for area A. You have to go very carefully from here, because there is real calculation, not just a squared easy one, because maybe you never need this area, but it's not question of your need or my need. Its question is how to chart out such types of formula. That's the important point. How to chart out that formula, because your analytical brain shall work when you do this. So let's start this sum here, and we can see that B776 over 2. This is A or 2. So this A or 2 plus 597, that is base, into this over 2 into 1.881 B776. This is formula of trapezium in terms of A. The dash is required here, and that's very, very important. So I've taken this area trapezium in this way. When I say B here, this value, this is A actually, it's written A here. So A or 2 plus 97A or 2 into 1.868 is that one. Then I say triangle area, right angle triangle here. This is cos 14 is here. So cos 14 is this. We have to find right angle triangle. There's an angle of 14, and for that, base over hypotenuse is equal to cos 14. And we have to find what? We have to find, base, and that is m is equal to hypotenuse cos 14. So that is, you can say B776 or B76 into D. That's what we find value of this. You can say base. We got there. So for area 2, this is just now feedback of triangle. So for area perpendicular into perpendicular base, so E tangent 14, perpendicular base equal to 14, perpendicular base. So perpendicular is equal to base into tangent. So 14 as well as there. So we can say, got my point? This value of something and this value of something. It says E7. This we are using this here. This value is being here used, and can say E776. That's this one. Or B776. That's this one. Base and this value, and into this is tangent of this. That's formula here. Perpendicular, so base and tangent, and we got this value. And then area square meter is 2. What is 2 area? Half into base into height. You must be a little careful here, because we are working on trigonometry. It's not normal calculation. It's a calculation based on your triangle, and we have worked on cos 14, and we have worked on this used in. Then we can say we found this and found that, and you can say that you can say here cos 14, this cos 14, and here you can say value of this, if we took in this and we multiplied by this value of this one, we got this one. So it depends on, so area or area 2, I'm saying it is area 2 half base into height, half into base E776 into height F776. So we got this. Although it's very small, doesn't matter. The triangle is very, very small. It should be small. Then we go to area 3. It's trapezium. Trapezium area 3, 6.3. 6.3, you can say 6.308A plus 3.481A. This is sum of dimensions, and plus 3.31A plus 1.5. Hybrid dimension of both sides we have to work out, because one side plus other side divided by 2 into A, or this height is formula of triangle, trapezium, and that's this one. You can see this dimension was given here. I've written here in this from that triangle, from that figure, 6.308, then A, and then you can say 3.4181, that's A, and then you can say, then 1.31, 1.031, 1.310, hold on, 6.308, then 3.481, and then 10.031, 10.031. Okay, 1.31, 1.546. Let me see which is area 3. Area 3. That's what I say is very, very important to understand this area 3. This is area 3. Area 3 is there, 63.08, and this is, this is your value here. You can take this plus this plus this. All these three you can take 30.581, 10.31, and then you can say, let us see how it's move back. Here, come here and see how it's working. This is area 3. This is area 3. We are taking 6.308. Then we are taking 3.481, and then we are taking 6.308. Let us see how it is there. We can just check 6.308 is okay. That's fine. Then 3.481 is also okay. Other side, but this side and this side are equal. So 34 I taking 3.481. That's okay. And then 10.31 is 1.031. It should be 1.031. So there's zero error, and then it should be 1.546. That's okay. So 1.031 it should be 1.031 rather than 31. So 1.031 it should be 1.546 is okay. That's okay, fine. So we change this value, so it becomes this one. So it becomes this one. So see, such errors do happen. So it is 1.031 rather than this. So we say 1.031 and not that one. So this point goes away. So this is okay now. This works now. The same thing as that. So 6.308, 3.481, and 1.031 and 1.546. So we get this value division by 2 and this one. So area 4 now. Area 4. This is trapezium. Area is called 1.688 A plus 2.188A division by 2 and A. So 1.688 A plus 2.188A division by 2 to B776A. We got area 4. Area 5 is area 3, the same as 3. So put such a sign here, put here. So we have got area 1, area 2, area 3, area 4, area 5 of this complicated figure. So area 6 is also there. That is area 2 and area 2. And we got area 7 as well. That is area 1. And then total area is 1 plus 2 plus 3 plus 4 plus 6, all 6. And this is, C776 here, 1. Area 2 is here, that is G776. Then H, area 3 at 776. Then K, area H. H is area 3, I is area 4, and J is area 5. Then K is area 6, and then area 7 is L, and we add up all these 1, 2, 3, 4. So let's say C776. Then area 2 is here G, area 3 is here H, area 4 is I, area 5 is J, area 6 is K, area 7 is L. So we got all areas here. We have summed up, and this is value here. Now for its total area. Now perimeter is also very important. In this case I have taken it in different same style, 8.246. that is this one, then A, then 1.546, and then 2.188, and then 1.546, and then you can say A, then 8.426, let's say, and then sum of all sides, that's external one, and it is from Q to B. We are taking external one, now internal one. What is internal one? 3.481, then we go to 1.688, and is this one, then we go to 3.481, and is this one. So we get sum of all these is 3, y, and AA. We got internal parameters. So external, internal, this is parameter external, this is W, and this is parameter internal. This is AB, and we get this value, internal plus external parameter. Extrusion, areas. Now where is areas we see? Is it M? We have to confirm M or not M. Let's see how much it is. This is area here. This is M, okay, fine. It's M, and M is okay. So we say extrusion is here. So it is M, this into AD, that's fine. Now area, is it twice and area, we say twice and area plus parameter C. So that is M here, AC, the sum of two into extrusion. So we got our V result. V or A is A, not V. We got our A result, which is of course, it's not easy. It's difficult from first angle, first viewpoint. It's not that easy, but we have to understand how to do that. You cannot say everything is easy or difficult. It's A, so I put it in A form. So it's better so that it remains there. It remains there as usual. So A, actually, real shape A is the result. We got it. But I didn't I repeat. There are certain dimensions. If you go to that geometry, you'll find certain dimensions. Those dimensions only for finding out formula, not for use. This shall change depending on your A, depending on the variance. These dimension angles or the angles won't change, and symmetry won't change, but only variation would be on dimension. If one dimension change, A change, everything shall change. That's only here. If this change, for example, I say 5, let's say 5. See, change, everything changes. If I say 25, again everything changes. You see, that's what we have to see. All of the points remain same. You say, okay, let's say 20 is 50, I say 50. So again it changes. This is what's the requirements. So we go back to 10 and see what we did. We dimensioned it, and from the dimension we converted A in area 1, that is trapezium, area 2 rectangle. You can say then worked out rectangle here. Area 3 trapezium, area 4 trapezium, area 5 is symmetrical, area 6 and then 7, like this we added together. And similarly we worked out the parameter of this and shape and worked out. So just repeating because to clarify. So letter B. Now these are all complicated here, that's why I want to take time on that. See, a long one, you can say, area B. You can see this one, Actually, it's not imaginary B, which you use in the writing. That's B, this one. And you can say there's two curves and semicircular curves here. This is a rectangular area. It's all rectangular, but this area is curved one, curved of 25, I think, 22.5 external radius and 12.5 internal. Mm-hmm. 22.5 here and 12.5 here, so that is 10, and 17.5 here. Similarly, it is here, but this extent is a little protrusion this side. This area and this area are different. So area 1, area 2, area 3, area 4, area 5, area 6. Once again, this is internal side, 25 here and 25 here, 17.5. So this, of course, this is more than that. So this is 17.5, and this shall be more than that, of course. So it is 38.5 here, and we can just check dimensions of this in a professional way, because this 8A, this is 2.5. And we can say 22.5 plus 17.5, and this is then 27.5, and you can say 22.5. So if you add up all them, it should be same dimension. So 10 plus 17, 25, 27.5 here plus 22.5 here, so this is 50. So this is 50 here. Here is 50, and here is 60. This is the difference. So 38.5 plus 22.5. So also you can say same thing comes 6A, and this is 5 in fact. And this is what we have to decide. This dimensioning of a non-symmetrical figure is very important. So this in this case is 1, 2, 3, 4, 5, 6. 6 areas, and similarly parameter. Different types of parameter here, rectangular parameter as well as circular parameter, semicircular parameter. So external and internal. So there's a lot of in this. And this diameter, you have to remember this radius, 12.5, 22.5, this is the middle one, is 17.5. And we have to remember this, and external, internal, we have to remember in this case, and we can say, okay, we understand that now. What we have to do? B, what we have to do is, that's important one, and here is, already about, I think we are going to 2 hours, and maybe after that I may not be able to continue because of cold and because of I'm tired, and tomorrow take it again if possible. Let me finish this one better if I can finish this one. Letter B, what it says. First of all, let me see. This strip is very long actually. You can see how long it is going, right? It's going how long? So I'll just tell you briefly. Tomorrow I'll explain to you what I explained to you this one. So it's to strip it, the area 1, area 2, area 3, area 4, area 5, area 6, area 6, and total area. So then total curved area, and then sum of 2 areas. So it's long one. I say here, area 1 is, this is rectangular, and this is 2.749A, according to that, 2.749A into A, right? 2.749A into A. So this we have, I got this 2.749A from dimension, worked out dimension, real dimension from that drawn figure, and that is converted in terms of A. This means if I say 2.7449A, this means it is 27, in this case 7, it depends on this, what value is this. Though it's not linked to this, hair's length, 27.49 actually it is. So area 1 is 2.749 into A. So this is 2.748. We got this value. Area 2 is 6A into A. So this is 6A into A. Area 3 is 1.75A into A. So this is 1.75A into A. Area 4 is 3.834A into A. So this is that one. Area 5 is now, see what we do? What I said, mid-arc. There are 3 radiuses. One is external one, 22.5. One is internal, 12.5. And the other one is 17.5, this middle one. So mid-arc length A, where arc length is equal to pi r, the semicircular, not pi d, pi r. So pi r, where r is 1.75, say 1.75A. So I use that one here, pi r, I use r as 1.75A, 1.75B here, because A is 1.75B is, and then width of B, same width. So we get area 5, right, using mid-length of arc. So mid-length, or you use difference of semicircular areas, which is long one, but because it's the same thing I tried and got same one. Now area 6, mid-arc again, because 5 and 6 areas are of course equal. So it says mid-arc length, and where arc length is equal to this by same thing as it was. So I calculated separately, but there is no need. If you want, you can just, but no problem. We calculated, so nothing wrong. Pi 1.75B into B. Similarly here, pi 1.7. So this area 6 are wrong. I mean to say, worked out. Total area, plane and rectangular. Plane or rectangular, I am not calling rectangular, or I can plane to, there is no curve in this. You can say. So we have two calculations here. One is for plane or rectangular area, and other is for curved area. Rectangular area is some C and F. you can say C, D, E, F. These four areas are rectangular or plane areas, so I am taking them separately here. Only C to F, we get this area. And semicircular areas we are taking here, curved areas or semicircular areas, curved area you can say, or you can say semicircular area, or curved or semicircular you can say semicircular areas, semicircular areas. Circular one, so it's same, there's no difference. You can say sum of this to G and H. This is G and H. So we get these areas. So we have two parameters now. One is for this area, other one is for this area. Some of them you can find, although it's not used separately, even then it's a forgot per se. This is I and J. So we sum up here. Now this is only for area. Now parameter here is a different one, external rectangular, internal rectangular, and then different one. First of all, external rectangular, internal rectangular, and then we have to say, okay, this is that one. Now first we have to work out rectangular, and then circumference, because this is parameter we are saying. Parameter is applied to shape of rectangle or otherwise on curved surfaces or on circular surfaces or semicircular surfaces. We have to apply circumference. So this is circumference, curved upper and radius internal, and then circumference, curved lower. Curved upper and curved lower means this is like this. I'm calling this upper and I'm calling this lower, right? This upper and this is lower. So it is a little long calculation. That's why I was hesitant to continue, but no problem. Let us say here external rectangular area, which is here. I just for information, I can say this is external, this is external rectangular area, right? And this is internal rectangular. Don't count curve here. Only this area, and internal is this area, and this area is lower and upper. And similarly, you will find there that's especially in this curve portion, because it's always complicated. But this is mathematics. Nobody can deny this fact. Now external rectangular says 2.75a. That's 2.75a. 8a, this is 8a, and this is 3.85a. This is 3.85a, and this sum of all sides can say and P, and this is that. We got this. This is external rectangular. Now we'll go to internal rectangular, upper one. First we are saying external. Now internally it's upper and lower, so 1.75a, which is this one, and 2.5a, which is this one. And then we can say, okay, 1.75, which is this one, and this is this one. And sum of all this is three values, STU, we give this one. Then lower, I'll say lower one. We go to lower one and say 2.5a, this is this. Then we go 7.85a, this is this. And we say, okay, sum of these two values is this x and z. I mean, those three values are here, x, y, z. So it is here, sum of these two. Now, external internal is here. This is q, that is here, this is q here, q. Where is that? Sorry. Yeah, it's a q. This is sum of all, that is this one. External, and then this is, here, internal, and that is this one, perimeter here. This is V, we got V, and then AA, he says AA, that's what AA. AA is a total parameter, so sum of all sides. And external and internal is this, three values, AA, total parameter, sum of all sides here, then external plus internal regular, this is Q, V and AA, whereas Q is this one, Q is this one, and is external, and V is here, internal, and then you can say lower also, you can say here internal lower, rectangular lower, and then we got this, sum of all sides. Then we got sum of all sides here, and we say now we start off, circumference here, circumference, curved upper, and radius internal, this is this one, then radius external, this is this one, two external, 1.25 and 2.25, so circumference curved one, and that is radius internal, 1.25a into pi r. So this is, pi r can say. This is radius internal is this, so we find 1.25a, pi 1.25a, internal external is 2.25a, pi this 0.25a. Internal, the circumference curve lower, this is upper, and this is lower, 1.25 pi r, and this is here. External radius external is this one, so external radius 2.25a. I'm just trying to give you our total circumference says, because we got separate curves here, so we got total circumference 1.25, we got 2.25, we got. So external and internal, because internal address is this and external is this. So you have to have separate values for upper and lower, and we can say that we got this value. Total circumference is internal is this one. This is our internal that is AD and AG. This AD and AG, and we can say external is AE and AH. This AE external and AH is external. So we got this internal external, and sum of this is AI and AJ. This is AI and this is AJ. We got this value here, and then we come on to extrusion, which is, of course, same. We can say volume cubic meter in plane area, volume cubic meter of curved area, and then plane rectangular area, and then curved surface area. There are so many parameters developed in this case because of curved one. So we can say volume is, first of all, this is plane area, and saying AL. AL is extrusion. Why goes to I? Because I is here. I is here, you can say. I is total area, that's rectangular plane, so that's I. So we put on I here rightly, and I say that, okay, this is I, and we successfully say rectangle is okay. This is 2I, I into AL is extrusion. We got this volume of plane. The curve is here, IJ and AL. Now, where is J? J was here, if you say curved area, that's J. Means you have to go back. This is J here, it's total area curved, semicircular, in this J, so we get J here in, and we can say that this is volume J into AL. We got volume of plane surface as well as curved surface, both volumes we got. Now, parameter, used to parameter circumference. For parameters, parameter, it is surface area 2 end areas plus parameters 2 end areas there. I it was there, AB into AL. This is AB here, AB into AL. AB, I can say parameter must be there, and that AB is parameter. Where is that? Let us see. AB it is saying my calculation. So AB it is, and it should be AB here. External rectangular parameter into, and that is your extrusion value. 2 into end areas plus this and extrusion value. And here it is A2J. The J is a similar area. As I said, that is for curved surface, so you can say J, and it is here. J, this is a curved surface area, 2 end areas plus AL. AL is must be AL. AL, it is here. JKL, that is extrusion. I know extrusion value, and AK. And AK is internal, external, that is circumference, internal, external. So it's that one. Actually, sequence, it should be AL. AL should be here. I should take this one here better. No problem, however, sequence is same. So we can say AK, I can make it AK and AL. This is the same thing, I make it AK and make it AL. So that sequence is same, no problem at all. Value remains same. So it is AK. AK is value of parameter, circumference, and then AL, and that is extrusion. So it remains same. You can say this way, or you can say this way. It is same thing. It doesn't matter. So it's complicated, must be resolved. I'll explain next time because it's a little difficult. And same way to go see this time there now. Let me see. Oh, it's already 2 hours and 9 minutes. So I think I should close it now. I'll continue tomorrow because there are so many more cases, 9, 10 letters, and it is B. You can say it is B, it is one more C, then it is D, then it is G, then it is J, then M, then N, and then O, and you can say P, and then you can say Q, then you can say R, and say S, you can say T, U, W, and X, and you can say then 1, 2, 3, 1, 2, 3, 3, 4, 5, 4, no, 3, 4, as well as 5, 6, and then 7, 8, 9, 9, and 10. So there are so many still left, and we can't cover it one day. So these are, I'm just showing you diagrams of this. This is 0, and this is another 0. This is 9, and this is another 9. And this is 8, and this is another 8. And this is 7, and this is 6, and this is 6. This is 5, and this is 3. This is 4. And here you can say 3 is also very, very complicated. And it's here 3, it can't be done in one time. It's 3, then it is 2, and then it is 1, and this is, X. Then you can say, we just done this, and I don't know which one is that. Let me see, W or what? Yeah, W, it is W, sorry, it is W, and then U, and S, and R, and this O, P, O, like that, and M, J, so we have reached there, and J, and this G, and then D, real one, C. So we are reaching C now. So that's what I say. We are reaching C. So we should be a little clear about that, what we have to do. And I'll do that. So I think we should close it now. If you feel happy, we can't continue more than this. It's already 2 hours, 12 minutes. I wanted to continue, but because I started late, I wanted to start at 5 hours, 5 o'clock, but I was delayed due to some reason. So I could continue for 3 hours, but it didn't happen. Tomorrow will take another 2 or 3 hours, possibly, because this is a very, very complicated one. This real one is very complicated. So I think you'll appreciate something is better than nothing. And at night, it takes time. It's very cold, and I'm also going to take rest. So I hope you got this presentation of little use. From some use, you can say, you may use this in your, actually it's a presentation how to use this cells, this sheet, which is very, very complicated one. If it is otherwise, it's very easy. You just do ordinary work. If you do very scientific work on this, it can be very useful. So that's the whole purpose of this. And I think I have drawn this first. You just think this way. It's not simply I'm presenting to you now. It's drawn before do that, and that takes a lot of time. Drawing, thinking, it's kind of complete scientific engineering work. It's not simply geometry. It's engineering work, to be very frank. It's science, to be very frank. What's in mind's not clear. When you draw it, you find so many problems. When you find and think and do it, a square is very easy, means you can select square, rectangular shape, but when you come into curved one, circular one, semicircular one, otherwise quarter one, and that causes really how to handle this, how to use angle or use direct dimension. It works that way. And that's really interesting. Means once you start thinking, then you generate yourself many more. And that's where I stand that in those shape means, but it's mind-blowing how to handle, how to find it best possible manner. And then in terms of some A like or some one variable like, and then take another variable of vertical extrusion, that is, as you say, volume or it's in surface area. So two variables are there. One is direct one, that's dimension. I will dimension in that proportion, and the vertical is also in that proportion. It's what we are doing. I'm doing just, I don't know, you do it, you like it, you don't like it, but you may use it in your life, or you may work out some other shape if you wish so. It can be done, no problem at all. If your conception how to do it, once you establish it, once you can say, make application of this, and then you can enjoy it. So I close it with this, with comments. Thank you very much. I stop sharing now.